Good morning. Today we are going to be answering a question that requires us to apply some concepts in combinatorics to a word problem. So let's picture this. Let's imagine that a group of people are waiting for an elevator. And specifically, we'll say 9 people are waiting for this elevator. And when the elevator comes, it's going to be empty, but it also has a max capacity of 4. So at most 4 people can ride this elevator. Our goal is to decide or determine how many different groups are possible to ride up this elevator on the first ride up. But let's take a little bit of a closer look. 9 people are waiting for an elevator. The elevator is empty when it arrives, but it can carry a maximum of 4 people at a time. How many different ways can we form a group to take the first ride up? So let's pull out the key pieces of information that we'll need to know here. What is the problem giving us to work with? That's going to be the 9 people who are waiting. That's the group that we're going to have to choose from. And the 4 people that we can fit in the elevator at a time. And that's the group that we're going to be choosing, at least at first. And ultimately, we want to decide how many ways can we make a group of a maximum size of 4. Now, before we dive into the specifics of this problem, it's going to be important to note here that we're going to be counting combinations, the combinations of groups that we can put on this elevator. And so let's talk a little bit about how to count combinations in general, and then see if we can apply that to this specific problem. We say that the number of combinations when R items are chosen from a collection of n is given by the formula n factorial divided by n minus r factorial times r factorial. And now notice I'm going to use this notation here primarily, but there are a few other ways that you might see this as well. You may see this more in like a traditional function notation, the number of combinations choosing r from n. Or you may sometimes also see this with subscripts. So you may see it subscript n, capital C, subscript r. All 3 of these represent the same idea. This is telling us the number of combinations when we have a collection of n and we're taking r items from that. And so for our specific problem, our collection that we are choosing from is going to be those 9 people that are waiting for the elevator. So we have n is equal to 9 in our case. If we want to choose a group of 4 people to ride, now that's the max number, but if we want to choose a group of 4 people to ride, we'll be choosing r is equal to 4. Right? And we can count that number with our formula. So we can say, okay, we want 9 choose 4, 9 people, and we're choosing 4 to go on the elevator. That's going to be 9 factorial divided by 9 minus 4 factorial times 4 factorial. We can simplify this, of course, which would be 9 factorial divided by 9 minus 4, or 5 factorial times 4 factorial. And if you wanted to write the entire expression out, when things start to cancel, this would be 9 times 8 times 7 times 6, and then 5 through 1 would cancel because of this 5 factorial on the bottom, divided by 4 times 3 times 2 times 1 from this 4 factorial that's still left over. And so if we were going to compute this, we would get 126. So when we have 9 people waiting for the elevator, there are 126 ways we can take from those 9 people and put 4 of them on the elevator. We're not quite done yet, however, because all that was stated in the problem was that there is a maximum number of 4 people that can ride this elevator. But that doesn't exclude that we could have 4 people who ride, or maybe 3 people who ride, or maybe 2 people who ride, or 1 person, or nobody could go up on the first ride. And so all of those things are also options as well. So we're also going to have to compute 9 choose 3, 9 choose 2, 9 choose 1, and then also remember the one option at the end where this would be as if no one rode the elevator. But we can apply the same formula to all of the rest of these as well, right? Here we would have 9 factorial divided by 9 minus 3 factorial times 3 factorial. Here we would have 9 factorial over 9 minus 2 factorial times 3 factorial. And lastly, of course, we would have 9 factorial over 9 minus 1 factorial times 1 factorial. Now, I'm going to leave it to you to go ahead and compute all of these out the way we did the first one, but I'll tell you that if you do that, you should get 84 for 9 choose 3, 36 for 9 choose 2, and of course 9 for 9 choose 1. Now, since we have all of these different possibilities, we could have 4 people ride, or 3 people ride, or 2 people ride, or 1 person ride. We have to take each of these numbers and then add them up. So we would say in total, between all of those different options, we would have 126 plus 84 plus 36 plus 9, and then plus the one option where nobody rides, totaling up to 256 combinations. Okay, and this would be our final answer. So if 9 people are waiting for our elevator and a maximum number of 4 people can ride, there are 256 ways that we could group them together to take the first ride up. I hope you enjoyed the word problem today. If you have more suggestions on word problems that we can work through, don't hesitate to put those in the comments below, or any other question that you might have. I hope you found this helpful, and I hope it at least helped give you some sense or help get you started on how we might take the idea of combinations and apply it to a specific example. But thank you again for watching. I hope you have a great rest of your day.